The population of the town of Decrease, now 11800, is decreasing at the rate of 120 people each week. Population of the town Increase, now 2200, is increasing at the rate of 80 people each week. In how many weeks will these two towns have equal populations? So 11800 minus 120x, where x represents the number of weeks, and that is equal to 2200 plus 80x. So this is the mathematics based on the question. So now we just have to solve this. So this will be 9600 is 200x. And when you divide through, you get x equal to 48. So 48 weeks is the answer. What are the only three positive integers that cannot be the length of the shortest side of a right triangle whose side lengths have all integral lengths? Okay, so we have a right triangle, and they're saying the shortest side. Let's just say that's the shortest side. They're saying what numbers can that short side not be? Okay, well, let's see here. And they're saying they're all integers, so positive integers, obviously, because they're lengths. So let's just make the list of the first few, and let's see. We only need 3, right? So let's see if we can get 3. Okay, well, the first thing that comes to mind are just looking at the Pythagorean triples. Pythagorean triples. And some of you may remember, most of you remember at least one, right? The most famous one is a 3, 4, 5, where this side's 3, this side's 4, and this side's 5. That's by far the most popular Pythagorean triple. And in this one, the shortest side is 3. So 3 is possible, so we'll circle it. Because eventually we want to get numbers that cannot be part of a Pythagorean triple, which is basically what this is, since it involves a right triangle. Okay, now some of you may remember a few more Pythagorean triples, right? Let's see, 6, 8, 10, that's another famous one. And if 6, 8, 10 is a Pythagorean triple, the shortest side is 6, so 6 is possible. And another one, I think I skipped over it actually, probably should have put it there, is 5, 12, 13, I believe. That's a Pythagorean triple. 144 plus 25, right? Yeah, some of these I should know all of these. I'm just starting to forget them actually, but I'm pretty sure that's a Pythagorean triple. And the shortest side here is 5, so 5 is also possible. And similarly, you can go through others. There's 7, 24, 25. Shortest side is 7, so 7 is possible. 8, 15, 17, I think. So 8 is possible. 9, 40, 41, if I remember. So bottom line is, you can see that all of these will be possible. The only ones that are not possible, which is what the question is asking, are 1, 2, and 4. Those could not be part of a Pythagorean triple where those numbers are the shortest side. See, in this one, 4 is one of the sides, but it wouldn't be the shortest side. So that's all they're looking at. A circle of radius 5 is circumscribed about an isosceles triangle. If the length of the altitude to the base of this triangle is 9, what is the area of this triangle? Let's draw this a little bit bigger. And then let's see here. So we got the base. We got the center approximately here. And let's just join that. And then let's draw a straight line. Okay. So I think that should be good enough. Now, what do I do here? Well, I think, what are we asking for? The area. So the area is equal to 1/2 base times height. Okay, well, first I'm going to join this from the center to the edge, and that's a radii. Now the radii is 5, so that means that's 5. And then the distance from there to there is also 5. So that's also a radius. And then the altitude they're saying is 9. So from this top to this bottom is 9. So that means this distance here, I'll just use a different color. This distance must be 4. And then this is a right angle since that's the altitude, and then therefore that's x. And actually, we just talked about this. That's a Pythagorean triple, and that's going to be equal to 3. And you can verify that with Pythagoras. Okay, so if that's 3, then this side is 3. So we have it all. The base will therefore be 6. The height is 9. And 1/2 base times height would be 27. If x is a real number, at most how many integers can lie between the numbers x minus 2004 over 2005 and x plus 2004 over 2005? Okay, so we have x minus this guy, and then we have supposedly some integers, and then we have x plus 2004 over 2005. Now, you are allowed to use a calculator, so let's just figure out what this is. This number here, I think it's a very small number, so it'll be 0.000498 and then dot dot dot, right? And then similarly, x plus 0.000498 dot dot dot. Okay, so to get a basic understanding, let's give x a value. So let's say let x equal 1. You can let it equal anything you want, 100, whatever you want. And let's see what happens. If it is 1, then this term becomes 1 minus that. So it would be, it would be, well, I guess I have to use my calculator. Sorry, I know why I got confused, because the value of this is actually not what I wrote. It's actually 9995. I jumped ahead there. Sorry about that. And this is be x minus that. That's where I got it. I jumped ahead. So that's 0.9995. And then when you use 1 and for x and then subtract it, then you get what I had actually written. That's okay. At least I caught it. So then what you do is you take that number and you subtract it from 1. And then you get 1 minus 0.99995, which is 0.000498 dot dot dot. Got it? And similarly over here, you get 1 plus 0.9995, and that's just going to be 1.9995 approximately. Okay, so now what you do is, what I'd like to do is just put it on a number line. So if you have a number line, let's just use a different color here. So we have zeros here, and we have 1 here, and we have 2 here. Our values, this guy is around here. It's very small, very close to 0. And this one is very close to 2. So they're saying how many integers are in between. Where in this case, there's only one integer in between, and that is 1. So let me just put that 1 there. But they're saying at most, is 1 integer the most we can get? Well, what I'd like to do is this range here, I'd like to shift it a little bit. You can shift it to the right, you can shift it to the left, doesn't really matter. Let's shift it to the right. If I shift it to the right just a little bit, so for the sake of clarity, let's just draw this again. So this is 0, this is 1, and this is 2. That range, if I shift it, let's say, so that it goes a little bit beyond 2 this time, like that. So this is now here, this guy is now here, and this guy is now here. If I do that, then what I'll be able to do is get 2 integers to lie in between. You see what I'm saying? So that basically means that you would have to change your x to be something a little bit bigger than what you had before. Before you had x equals 1, you can put x equals 1.2, let's say. If x equals 1.2, then you'd get one value here, and then you'd get the other value over here as slightly more than 2. And therefore, you'd get 2 integers like we did here, and 2 integers is the most that you can have in between those 2 values. One Halloween, I was caught by 3 witches, one after the other, in succession. Each witch fed me 1 zucchini from a pot, then took 1/3 of the zucchinis left in the pot, and then flew away. All 3 witches used the same pot. After the 3rd witch flew away, I destroyed the 6 zucchinis left in the pot. How many zucchinis were in this pot before I was caught by the 1st witch? First, before I get into letters, let me just use some numbers just to explain. And you can use any numbers you want. Let's say initially I had the pot had 100 zucchinis. The 1st witch feeds me 1. So now I'm down to 99. Then the witch takes 1/3 for herself. So 1/3 of 99 would be 33. So she would take 33. And then remaining in the pot would therefore be 66. So I'm just showing you that as an illustration with numbers. And then that kind of continues from there. And we have 3 witches. So you'd have the 1st witch, you have the 2nd witch, and then you have the 3rd witch. Now, with this one, I started with 100, right? Just as an example. That is my goal. I have to figure out what that original number is. So I don't know. So since I don't know, I will call it n. And then we'll go through this process. So initially, 1 zucchini is fed. So I'm left with n minus 1. Then the witch takes 1/3 of that, which would be 1/3 of n minus 1, and leaves the other 2/3. Got it? So that is the process for the 1st witch, but this time involving the letter n, since we don't know what n is. Here we have to figure that out. Okay, so let's continue this process with the 2nd witch. Same story. We take the number that is remaining, 2/3 n minus 1, and we take away 1, just like we took away 1 here, or 1 here, I should say. And then the witch takes 1/3 of this and leaves 2/3 of this whole thing, which would be like this. Got it? Okay. And then one final 3rd witch will take 1/3. She will take away 1 first. So let's do that. So this whole thing, she'll take away 1. And then we'll leave 2/3 of that whole thing. So you just got to make sure that you do this properly. And I believe I have done that properly. Okay, so now that is how much is left, and they told me that that is 6 zucchinis when these 3 witches have done their distribution. Okay, so then therefore make that equal to 6, and this is the mathematical equation that you now have to solve. It shouldn't be too bad. Here we go. First, let's cross multiply. So 6 times 3 over 2, and that's going to equal 2/3 n minus 1 minus 1 minus 1. Let's see if I did that right. Hopefully I did. So this 6 times 3 is 18, 9. And then let's just bring this 1 over. So that's going to be 10. And that's going to leave me with 2/3 n minus 1 minus 1. Okay, now cross multiply again. So 10 times 3 over 2. And then this is going to be 2/3 n minus 1 minus 1. So that's 15, and then let's bring this 1 over, so that's going to be 16 is 2/3 n minus 1. And then if we cross multiply once more, 16 times 3 over 2 is n minus 1. So that's what 24 is n minus 1, and therefore n is 25. And I'd like to verify that 25 is correct. So we started with 25. The 1st witch fed you 1, and that means you had 24 left. That witch then takes 1/3 for herself and leaves 2/3. Okay, next witch, starting with 16, feeds you 1, that leaves 15, takes 1/3 for herself, leaves the other 2/3, that's 10. And the final witch takes 1 for herself, or feeds you 1, I believe, and that leaves 9, takes 1/3 for herself and leaves 2/3, and that would be 6. And 6 is indeed how many were left. So we verified that we've done this correctly. What is the ordered four-tuple of the positive integers x, y, z, w, each as small as possible that satisfies the simultaneous inequalities? All right, so all these inequalities. All right, so here we go. So we have to fiddle around with this. Boy. So where do we go? Well, let's see here. 2z is less than y plus w. Okay. So I'm trying to see if I can make similarities here. That means if I do a z minus y, that's the same as w minus z. And w minus z, I think I can get that in another way. With this one, x plus w and w, so y plus z, those have the same letters. So if x plus w is less than y plus z, yeah, I can get w minus z is less than y minus x. So what that does is allows me to kind of combine these into one. So that means that if z minus y is less than w minus z, and that's also less than y minus x. Okay, so that's doesn't seem like a very good start, but at least it puts everything together. Okay, so now at this point, I want to make a little bit of a comparison. We're going to use, let's say, I'd like to use this guy here, the 2y, the x plus w, and the y plus z. Those three in the middle there. 2y less than x plus w less than y plus z. Now this is the same as like y plus y is less than x plus w is less than y plus z. Now that basically, since all of these are integers, right? Since all of these are integers, there has to be at least one difference. Like for example, if this was equal to 2, this has to be at least 3. It could be 4, 5, 6, anything, but it has to be at least 3. And similarly, this has to be at least a 4, since they're all integers. There's no decimals involved. It's because we're looking at, I think, the smallest as possible. So we want the smallest numbers, so that's why I'm looking at the smallest possible increment. Okay, so what that makes me think is, since if we're comparing this guy to this guy, y plus y is less than y plus z, and then therefore we get rid of the y's, y is less than z, but there's got to be at least two different, a difference has to be at least 2. So z has to be greater than y plus 2, greater than or equal to. Yeah, or the other way of writing it is z minus y has to be greater than or equal to 2. Yeah, I think that's the right way of saying it. Okay, so now that we have a whole bunch of hopefully helpful inequalities, let's substitute something in and see if we can get some actual numbers. Let's substitute x equals 1 because we want the smallest, right? And x is the smallest, I believe. Yeah, x is the smallest because you got 2x here, 2y here, 2z here, and 2w. So that basically means that 2x is less than 2y, is less than 2z, is less than 2w. So that means that x is less than y, is less than z, is less than w. So x is the smallest. And since we want the smallest numbers, let's start with the smallest positive integer. Because they're all positive integers, right? Yeah. Okay, so let's start with 1 for x. If x is 1, I'm going to be able to figure out all the others, the numerical values. Okay, so I'm just going to go back here. This one was fairly helpful, so let me just go with that. Z minus y less than w minus z less than y minus x. And this one, since z minus y is greater than or equal to 2, and I want the smallest possible numbers, I'm going to use 2. So I'm going to set that to be 2. And the smallest possible would be if that's 3, and the smallest possible would be that if that's 4. And maybe that will solve it. So with this one, since x is 1, if y minus x is 4 and x is set at 1, that means that y will be 5. Correct? Okay, so now we can go to this one. If z minus y is set at 2 and z minus 5 therefore is 2, then z is 7. And then finally this one, if w minus z is 3, then w minus 7 is 3, and therefore w is 10. So my 4-tuple x, y, z, and w is 1, 5, 7, and 10.